So what I expect from class is I want you guys on time every day. I want you guys to be proactive, not reactive. What is difference in proactive and reactive as our class perspective? Who will define it? I mean, so proactive, if we are taking positively, we are participating in the class. If we are proactive guys, if we are not reactive, we know okay, we are here to listen, and as since first day I'm saying it doesn't matter, maybe you guys know better than me, right? But the thing is, when we are sharing the knowledge, we should listen like this, we need to absorb it, right? And if we are reactive, we don't absorb, we just listen to answer, right? We don't need to listen to just answer, we need to absorb it, right? So we will be moving onward with a proactive attitude. So be focused on concepts clarity. Don't think if sometimes lab is not functioning properly, if what I have written on the board you guys could not write in the exact form. But the thing is, these things are tools to understand. These things are not we are going to learn, right? If we are doing the labs, if we are doing something on the board, these are the tools for learning purposes, for concept clarity. And as I have mentioned earlier as well, if we know the concepts, we can do each and everything in the production. Google is there to help us out. But if we don't have concepts, then these Google things don't work at all because we don't have confidence. So what should I do? Go for these steps or not? Who are the steps available on the internet? So if we have concepts, then we can do anything. No problem at all. So I always say work hard in silence and let success be your noise. So we don't need to say anything, right? Our work should say something. So always deeds matter, human doesn't matter. So these are my expectations from the class, and what your expectations are, or your best way of learning from the class. So you have no idea about IT so far, right? Mm, right. So what's your best way of learning then? Do you listening the videos, or just listen the teacher? You need the paper material, or you are good to go with hands on. June, hands-on,
I like more practical everything.
practical. So Uday did? You guys are no hands-on. Sir,
Visual learner.
visual learner. So hands-on not necessary. Hands-on. Sir,
I learned much from the book.
from
Book.
books.
Yeah.
So
I didn't need a book.
let me take
a
a
medals in Lena.com.
right.
Yeah, both with some material from internet, and I think what lab is maybe it's necessary.
So Simon,
House protection and all
What should I say? What type of you learner? You are the learner. What type of this learning is? YouTube, Google, as I said earlier, are the best tools, right? Nowadays. But how to authenticate, okay, what topic they have entered into the internet, that is exactly fine, good to go. I mean, me, Sharif, any can write something and we can throw into the internet. It doesn't matter at all. So if you are depending on those tools, then always search properly. They are helpful, no doubt they are helpful. Alden,
What do you think is the best way to research both hands-on and technical?
hands on. So unluckily in NetworkPlus, we have very less hands on. But from when we are moving towards the MCSA Microsoft stuff, then it will be way better. Most of the time we will spend on doing something. So Network Plus, it will be our roadmap for the class. We're gonna discuss introduction of the network. So what is a network types, and how we design the network, right? Network topologies. But it's all things will be just an overview. It's a bird view of the network. Then we're gonna discuss the open system interconnection OSI model. Those are 7 layers. So what it is, what happens at each of its layer, and how each layer works. We will be discussing those. Then networking component and devices. Hubs, switches, routers, firewalls, content filters, mail filters, right? Different things. And then IP addressing types and how it works, what the fundamentals for this, what is fundamental for it. It starts from binary, zeros and ones, and then how we assign the IP addresses and how we resolve these IP addresses to names, right? So those are DICP and DNS. And then routing and switching. First we said devices. We will be talking about hub, switches, routers, and then their functionality. When we say switching and routing, it means we are talking about their functionality now. So static, dynamic routes, and how routing tables get built, and then port mirroring, authentication, VLANs. What is VLANs? Visual, virtual. So virtual LANs. Then TCP/IP, then media, cabling, and then wide area network, wireless networking, what protocols are involved, what topologies are involved, what types we have, and then management and troubleshooting. In management, we're gonna learn documentation, the importance of documentation, monitoring fundamentals, and then different tools, sniffer, scanner, and the patches, security, networking tools. That's it. See how small this one is. And you guys were worried, okay, it's gonna take long time, right? So then, who knows what is network? Who can define network? I'm not seeing your fingers. Yeah. Simon, what is network? Be loud. You have done your breakfast? Not really. So, I mean, what is network? You guys said you in A plus you have covered in Network Plus as well. So, June, what is network?
For my own definition, maybe network is connection.
What is networking we have as a human? Over here, when we go at different, when we come to Canada, new to the Canada, we go to different centers. They ask us, okay, if you guys need to get the job, please have some kind of networking. So build your own networking. What those networking is?
Connecting to each other, communication.
So we are connecting with each other, right? There are connections. Human connections are there. We are creating the connections with other peoples. So then, I mean, what is network in computer world?
Internet
Internet.
and a part of that.
Okay, what else?
And
System or interconnected people or things.
Interconnected things or people. Good, sir, Sharif sir.
Network which makes you communicate with outer world, different computer or whatever you are using, like mobile and all those things. This makes you all this comes in network communication.
Yes, sir.
Group of nodes connected to a segment of media.
So if there is no media, then there is no connection. Pretty sure.
Of course,
Should I log it?
yes, please.
Okay. So it's a interconnected devices, right? What the purpose of the network then?
Communicate.
I
To
mean,
bring everyone together to get the sharing idea and
sharing,
Yes.
sharing, right? The whatever we have, either we have networking of humans. What we are doing there, we are sharing. If some mentor is there, someone is helping us to find out the jobs, he or she is sharing his own stuff, right? And we are sharing our ideas. We are telling him about ourselves, right? And he is telling us about the market and about different tools available to search the jobs over the internet, or maybe he is providing some connections. So what we are doing sharing. So connections required for sharing. So we can say interconnected devices to share the data, right? When we are talking about the computers, then we are sharing the data. What I'm doing, if I'm sending an email, I'm sharing, right? Just I'm sitting away, but I'm sharing. Right now I'm talking to you guys. We are in a connection. We are talking each other. It's a network. Our class is a separate network, and no one else is listening us, right? They have their own networks. In other classes, other networks are going on, and they are sharing their own stuff with each other. So if I say personal, when personal computer get introduced,
Personal computers.
yeah.
19, I'm just guessing, but 1987. Around there.
Late 80s. I was 73.
So does it matter to know when computer invented? So simply, you know, before what we were doing for sharing, we had files, we have folders, we were using those. Files were moving from one table to another table. Then this PC made a big change. Then we have everything on this PC. In the first time when they recognized, okay, if I have everything on this PC, how to share now these files and folders with others? How this file now can move on different tables? How we can share these things? And from there the networking started, right? At that time networking need came into existence, right? So we started moving. But it's simply, I would not like to go into the history of the CompTIA or the PCs. All written is here. The thing I want to discuss is when we build a home, what the first thing we do? Foundation. How can you build a foundation without any design?
Yes. First, first is the plan.
Plan. We plan something, right? Then we put those plans on the papers. And those papers we say it's our design, it's our map. Now this much rooms we will have in our home. Here it will be a kitchen, bath will be attached. We plan everything, right? We put those things on the paper and then according to those papers we start building our house. So what material we use?
Bricks and cement.
So immediate after designing, after planning, after putting the stuff on the paper, it's a map, then we think, okay, what is required to build this, right? And then we start picking the stuff. Okay, we need bricks, we need cement, we need this or that, right? So different stuff we started gathering, right? Then what we need? Workers who can build that, right? So we need some technical guys who can build our house. They can provide the labor, who can bring all those components required to build a house, can bring them together, can give them a shape. In networking, first we need to again design something, plan something, right? What companies does when a company starts, either they spend more time on designing or on building the stuff. See, most of the time goes to designing site. And who designs? Architects. How many levels we have in IT as job perspective? Three. Level 1, level 2, level 3. Where the architect falls? 4. There is not only level 3, there is level 4. There for architects. What architect does? Just design, right? To bring the things on the paper, on the table, right? And they are earning way more than us, right? We are implementing, we are working hard, we are bringing all the stuff together and build the big networks. But it comes later, right? The first design. So architect earns a lot. So most important thing is designing. When you guys are in different colleges, do they teach you how to design the things, how to architect the things? Only we learn how to implement the things. Why? It's too hard.
You have to know the foundation in order to design.
Never feel lost.
Very, strange. Most of the architects maybe will not be able to work like you guys. They can tell you, okay, do this, do this, do this. But when it implementation came, they cannot sometimes, and sometimes they do. As he's saying, we need to know the foundations. The guys who are going up from the bottom, they can do everything. But the guys who are coming from the top, they cannot perform the lower tasks. For lower tasks, they just can provide the guidance. So in networking, we design. What we gonna do in design then? What my network type will be, right? What first the requirements? What my requirements are? Either I need to connect only these 20 pieces together, or I need to connect the whole college in a network, right? Or maybe the whole city, or maybe whole region, country, or maybe the globe. The whole globe is my scope of work. According to the scope, according to the needs, we're gonna build our networks. We're gonna design our networks. And after designing, then what we need? We need bricks, we need cement, those things, right? So here we have devices, we have computers, we have cables, we have connectors, we have hubs, we have switches, we have routers, we have firewalls, we have plenty of type of devices we have. We use those devices to interconnect all of these pieces, and then what we do? Very small thing, sharing. We're gonna share the files, right? We're gonna share the folders, different stuff we need. That can be emails, anything. So I put one definition here: a collection of all these devices that are used to communicate and share information with other computers, other networks. Which those devices are? All of these. So after building a house, what we need? If it's a new, no maintenance required. But even then, after every year, we do some kind of paint, we do different stuff. So maintenance is required. Then for maintenance, what we need? Testing tools. When you guys buy a home here, what you guys do? You done some kind of inspection, right? And they use different tools to inspect the building. What the standard and what the no value of this house should be, right? They use different tools. So we need to testing tools to perform different type of maintenance as well. So we can come to know, okay, what type of maintenance is required by our networks now. So we can keep an eye on our systems. So we need testing tools, and then we perform maintenance. And for building the house or for maintenance, what we need? Administrators, as Kirik or Krik? Kirik. So as Kirik said, we need labor, right? So administrators are involved. All of these are the cost for any type of company, right? And then we need to secure our house as well. We don't want anyone to come in without any permissions. So we bring some security into our networks, and that is authenticated users should have access. So only family members can come in. Rest should knock the door and should ask for the permission. Can I come or not? If there is no door, then what? So we need to assign some kind of permissions. And then troubleshooting skills. If there are problems, if maintenance is required, we need to troubleshoot. And troubleshooting again done by some kind of administrators. Then constant maintenance and updating. What is constant maintenance in our systems? Good. Good. So everything should be up to date. And how we keep our systems up to date? Applying patches. Keep an eye on the loopholes if there are, and these things are being done usually through vendors. They do these things for us. They keep an eye on the loopholes, and they keep bringing the patches right to us, and we just apply those patches to keep our systems up to date. Either these are the firmwares or systems or whatever it is, right? So I even those are the applications, and patches for applications are there. Can we apply the patches just whatever vendors released? If Microsoft released the patches every second Tuesday of the month, we call it a patch Tuesday. So can we apply those patches immediately after the release? What should we do, Alden?
Make some scheduling for the patching setting the time when you open your computer. So that's
Test first and then
Test first before applying. What we need to test?
like update anything that's related or any vendor that presents a new update. It has to be tested first before applying to you.
Shrif, he is saying testing first.
First we create a permission.
Against what we test it?
We need to test in not in the real production. Not in the production. First we need to test the things whatever we are giving the patches is going to be harmful to your system. It's going to be give you any lag performance. So we need to check this.
So good. As Shrif is saying, we have bunch of applications in our environment, right? Either those patches are compatible for those applications as well, either they are going to upgrade my version, whatever, for example .NET framework, either it's going to upgrade that one or just it's providing a security patch. So usually as we have a test environment, and in test environment we have everything. Different type of application what we are running in the production we run in our test environment as well. So before applying the patches, everyone knows patches. What is patches? No? I mean, what are patches?
Doctor should know that.
Everyone knows what are patches? Updates, yeah. Fatma, you know? So why you are not asking? I'm just speaking, no one is stopping. Patches, you know, the updates. You know, every month your window asks updates are available. Those updates we usually in production we call patches. Most technical word we use patches. If you have a hole in any of your clothes, we can patch it, right? You know that patch? Rough, yeah. If you go do rafu, that's a patch. We are applying a patch. And
I was like, doctor should know patches.
doctor should know patches.
you would have done patch for people.
Yeah, you guys cut the skin and then apply the patch. First gives the pain and then resolve the pain.
They are the antivirus company.
So patch means if there is a hole, we just put something to remove that hole, right? To stop. No one can else come. If we have on patch on cloth, we are applying something. So air and we can save ourselves, right? So again, as we have holes in our systems, the companies are working on their system sites. They are making different systems. They are developing different applications, and the hackers are keep working as well. They are not sitting idle. They work more hardly, right? They work very hard. So to find out the holes from where they can get in to our systems, to hack our applications, to hack our data, to do something, right? So then when the companies come to know, okay, there are holes, we find some attack from some attackers, it means there is some hole. The company, the vendor then produce some patches. Their engineers keep working as well. So every second Tuesday, Microsoft releases a patches required to their systems. See how many holes we have in Microsoft Windows? A lot of. So then after these things, we have built our network, we have done those things. Then another thing we need to do usually, that is training, to train the staff. The who are going to use these network devices, we need to educate them as well. So then we different configurations are there. So this is the whole process we are going to discuss during this Network Plus class. We are not going to cover much design side. Design side, we are not going to design something, but how to design we're gonna discuss as well, just as a overview of that. And what we can cover in devices design topologies, right? What topology, what kind of topology we can use. So I'm going to circulate some stuff before you guys start sleeping. Let's bring something so we can keep awake, right? So let me copy the few ISOs. So guys, while we are copying the stuff, let's start discussing the stuff, right? So I was saying that if there is no media involved, this one, there is no connection, right? So you guys are connecting your USB drives to your PCs. Is it a network or not? It's a network. Oh, if you call it. Your USB is connected to my PC. Is it a network or not?
Yes.
You are saying yes. Andy, what do you think? Just connecting a USB to our PC or laptop, is it a network? How you will configure the IP to your USB?
It's a connection.
It's a network? So Ram?
I wouldn't say it's a network.
For internet,
More than
wireless internet thing, so your wireless internet users will then
No, I'm not talking about anything else. I just said simply, I just connected a USB drive to my laptop or my any PC. Is it a network or not?
No.
Khalid is saying yes, rest are saying no, and so Ram believes without this, why there is no network?
because it requires man power to deliver the data.
Manpower?
Yeah. So we put USB and we give it to
So
her.
you are denying women power?
Human power. Physically it's delivered.
Fatima says.
But like
It
man
means women, right?
For me, I think it's a network because, as we explained, what is network? We are sharing data already.
It's a network. When we are connecting to devices, it's a network. What we say, it's a personal network. It's form of a personal network, very small network, but they are sharing the data. We are copying files from PC to USB or USB to PC. They are capable enough to share the things. When they are capable enough to share the data, it's a network. They are creating a network. So if I'm for hub. So can I see it's on my PC? When I will connect my PC, I will connect with any wire, right? It's an Ethernet cable, patch cable. I'm just connecting this cable to this network adapter that we usually, installed on our PCs. It's get attached to our PCs. I cannot, carry the PC right now, so I take it as a PC, right? So it's a PC. It's a part of our PC, and you guys are using it. And use it as a hub or switch. So is it a network? What they are sharing? It's a switch, right? Or it's a hub, and one end we have a PC. What they are sharing there?
This is not a network.
Let me hide that.
This is a network. This is a network.
You tell me,
I
man.
don't think it's a network.
Why not?
Because the switch
Everything
is
is network.
no. Because the switch is not connected to internet.
Yeah, but the switch
What is
is the machine.
It's a type of device.
Yeah, but
They are sharing data to the switch.
who shares the data to the switch? This is the question. There is nothing now connected.
You're right, then why you're not confident?
It's not connected.
When see, we have system in our switch as well. We have system in our router as well. So when we connect any PC to our switch, again it's a network, right? We are connecting, as we discussed, bunch of devices. We have those devices and we are connecting any of them together. It's a network. Right now they are capable enough to share the things. So if it's the case, it's a network. Right now, okay, forget that this guy has system or not. I'm using another wire to connect to any other PC. No two PCs are communicating to each other using in between hub or switch or router. Router has enough port that can help us, right? So where the traffic starts?
Initially,
Yeah.
it's always starts from. So if it's a switch, it's different. It's a hub, it's different. So initially, it starts from the two devices that are connected.
So this one is a guy who is connected to our PCs. Within this device, system using different components to share the data, right? There is hardware and system is operating that hardware to share the stuff. What system is doing? System is giving an interface, right? What system is doing? That is helping to use these all of hardware components. Otherwise, we cannot use this the hardware components without any operating system on top of that. That helpful in operating these components. So if it's only a PC, sharing is within the PC. When we need to share the data to any other device, we need to connect. What's going on? So as we type anything here, it goes out to other machines, right? When we are trying to share. From where data leaves? From here, right? So from where we are connecting our PCs to PC or to other networks using this network adapter. As we, a few days back, we were discussing different components and redundancy, and we said redundancy is not required for this guy. We are just using the connectivity, nothing else. And the data, whatever starts traveling, starts from here. And how data travel from this place to another place?
Through the cable already connected.
any media, right? In between. There is one thing, when data comes to this frame, it packetize the data. They bring the data into different packets, right, into smaller chunks, and then it sends the data out. What we use that data, what the word is for that?
Data encapsulation.
Data encapsulation. It's a data, right? Needs to travel from one PC to another PC. In which form it will travel?
Wow.
If there is a copper cables involved, you guys have media are the wires. So if we are using copper cables, then electricity. And if it's a fiber cable, then what? Light. And if it's a wireless, then radio frequencies, right? Radio signals. So June knows way better than. Good. When we say copper cable and electricity, we are saying electricity is going through the wires. Electricity sometimes off and sometimes on. That's the only way we can read out the data. Otherwise, if the light is on all the time, electricity is on, we cannot figure out, right? Machines doesn't know. Data travels like this: 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 1, 1. So zeros and ones. When there is a 0, it means electricity or light is off. Electricity, no signal of electricity there. They are off. It's a light is off that time. It's like this. Right? Any, you guys can search light, and if you keep looking, it's like that. But it's too fast. So 0 is being on, off, and 1 means on. Off, on, off, on, right? So how the wires and these guys understand the data, the machine, not the machines. So what these ones and zeros are? Binary. So these are binaries, everyone knows. And what then zeros and ones are? What is only this one? Is 1 bit, right? It's another bit. So data travels in bits. And what are bits? Zeros and ones. Light is on or off. So if it's a data, how many bits in one chunk we can send through this guy, through network adapter? How many bits at a time? Who knows? Hmm? No. When we send, the data leave from this network adapter, and the data, this guy hands over to the wires to the media, and data travels on the media. That packet of the data we say is a frame. It always uses frames to send the data out. So they always use frame. Data when travels from this NIC card to another NIC card using any media in between, what we call the data? Frame. How this frame knows from where I'm coming and where I need to go? Speak loud. Simon didn't do the breakfast. You did? Oh my God. How data knows?
Addresses, physical address.
Physical addresses, what is physical address?
MAC address.
MAC address, right? So it uses MAC address. What is MAC?
A unique identification number. It's a unique identification number for each machine.
It's a code that is defined by the vendors for each NIC card or any device.
Which is like unique signature to that exact receiver or network card.
You guys
Easy access controls.
no, it's okay. It's still again, I'm just writing for the rest of the way.
I always like,
It's one and a.
I'm just trying to find out the way, because sometimes we are not at the same page. I'm trying to get the same page, but it flips around.
One, two, three, four, five, and 6. So media access control, it looks like this. What type of these words are?
Hexadecimal.
Hexadecimal. Hexadecimal, what characters are involved? Save, sir. What characters are involved in hexadecimal?
Numbers and data alphabet.
From which to which? What's going on there? So who's here? Excuse me. You have this one. So pass on that one. You have copy. Let me a copy for you, rest. Google. characters are hexadecimal. So hexadecimal, or sometimes we use just hex. 0 to 9 and A to F. So 16 characters are there. When we use hexadecimal, it's a set of numbers, right? Set of characters. In each set of characters, one digit, one character stands for 4 bits. In hexadecimal, in each this stands for 4 bits. And altogether, how many these are there?
64.
64, 28, 10,
No, 40, 48, yeah. I missed the last.
MAC address always 48-bit addresses. 4 and 4, 8, 8 into 6, 1, 2, 3, 4, 5, 6. It always gets written into six groups of 2s. So in each group we have 2 characters, and then we have 6 groups. So 6 pairs divided by hyphen key. So hash. So it's a MAC address. Where it get attached to? Source and destination. And I was asking something, how big this frame can be. When we send data from A to B, everything can get changed. Everything. What keeps constant?
Right.
No.
What is constant?
That's why I was looking. Did you do the job, did you, right? Very hard work. So Andy, what the size of this frame is? Maximum size.
Don't know. Which one? The frame. The frame? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So 10 altogether.
It's maximum.
15 bytes long.
Something less.
It's hard for me to write out like
49 2.
this number remains constant. What type of data we are sending, what we are doing, no matter what. The size of frame, since they invented the frame, it's same, 1500 bytes. There is behind of this, there is a calculation. We don't need to go into that. But if we just wanted to see how many zeros and ones are traveling on the wire from one bit card to another at a time, there is one bit, and how many bits in 1 byte?
Eight.
8. So these are bytes, 1500 bytes. So 1500 into 8. How many? Around 12,000. 12,000 zeros and ones move at the same time from one to the second. And then one thing more attached to it, this frame. What is CRC?
I would not say a word anymore. It's a check. Like, it usually checks for discrepancies, how the data flows A to B. It's basically separates.
It keeps a track, right? It's a calculation, mathematical calculation. Get attached to it, this frame. So how many bits are traveling at the same time, and what the sequence of those bits should be, how data should reach on the other side, all the calculations are here. And when the data reach to the destination network adapter NIC card, again they check against these calculations. If they match on both sides, then it's good. Otherwise, data is corrupted somewhere. So it's to keep the track for all of those informations. So whenever data starts moving from one NIC to another NIC, always it come into a packet, and that packet is called at this level frame. Frame travels from one to another computer, and maximum 15 bytes long, 12,000 zeros and ones, and this is the MAC address, how they find where to go. From where? Yeah.
So the 1500 bytes is for the whole frame,
Whole frame.
including the source
Everything.
one.
Everything. Everything. It's 1500 bytes long. The frame size. So do you send only these information from one place to another?
No.
No, man. Don't do that.
Send a lot of information within data.
Within the data, MAC is a physical address, right? And physical address limitation is
Physical layer. Physical layer.
Simon. What's your search says? No idea.
No results found. What is the question? You didn't get the
We want to send the data from, he's right. So data from one place to another. And if we are depending on MAC, what the MAC limitation is.
Too long.
Pardon?
It's too long. We cannot define a local internet.
Where are you looking?
Keep it weird.
What are the limitations for Mac?
Can we send just using the MAC address send up from here
Yes.
to any part of the world?
Yes.
Now, yes.
You can.
No, any part of the world, no. Yes, because the physical address is usually limited from end to end. It cannot be routed.
End to end?
So meaning within physical location. Physically. Just range server.
No, you cannot know other device MAC. You're not in the same switch. That's why.
Physically.
Yeah, that's why.
So these are the 4 devices.
Oh.
A wants to send data to B. So how it will send the data? Or it will come to know the MAC address of the B?
To all the devices. It's not intelligent. So it was sent to all devices.
Who is not intelligent?
No, I'm just something is. Yeah, hub is not intelligent, but it's not relevant.
I know we are not talking about this guy.
Yeah,
We are talking about this
Back
guy.
address, yeah. That's why I was like, no. I will send it to all the devices.
It will send to all of the devices. And the data belongs to which MAC address? It will keep the data and the rest will stop the data, or data get demolished right there. So always, who is creating the frame? Hmm? This guy. Who creates the frame and who demolishes the frames? So frames always gets generated within this network adapter card and eaten up by this network adapter card. So we are just these NIC generates the frames and eaten up the frames. So frames life starts from here and end from here, but it starts from one NIC and end on the other NIC. So always frames up to here, and we each and every NIC has unique MAC address. When you guys say our PCs have a unique MAC address, it means what are you saying? Basically, your NIC card has unique MAC address. What if you guys have more than one network adapters attached to your PCs? Fatima, what do you think? Then your PC will be unique. The device should be unique, right? So I said the MAC address is embedded to these network adapters. So if I have 2 network adapters in my PC, then my PC will be unique. How? If we have 2, then that PC will be unique or not? Fact. If I'm an A+ man, you guys kept playing with this guy. You should know the answer. What your addresses so PCs are unique?
Yes, it's unique. Yes, it is.
Pardon?
Yes, it's unique.
It will be unique.
I believe. Yes.
Simon? Do you agree? What Andy is saying? It's
I agree.
that's why I'm asking everyone. I'm speaking, everyone is sleeping now. So Simon, what the time is? Okay. Then go and okay. Have a break. We will start from here. If we are sleeping, no, no benefit. will recap whatever we have done so far. Let's would you try?
We are doing on the Mac address. We were doing on the data itself, right? We're talking on the data, how it passed through in bytes, maximum. So you can transfer by 15 1500 bytes. You can transfer at a time through network.
So we talked about networks, like what network is, and we talked about components of network, and also like network is basically interconnecting devices, computers, and how they communicate using media. And then we talked about how the data flows, and how we communicate, how we share data between those two components or devices. And we talked about how two devices work using MAC addresses as physical addresses, and how data travels from PC A to B with bits. We talked about frame and binary is the basically how data flows and how they communicate.
Whenever we type something in our machines, we type on our application, Microsoft, for example, Word document, and we start sending the document. The whole process starts from the application layer and comes to the physical layer, right? We don't get confused. We're going to discuss those things if we have time today, otherwise tomorrow. I purposely started from this network adapter because it's the main part in our networking that help us to connect to other devices and to share the data. As we said, it's a 1500 bytes that frame, and this number is not gonna get changed. It will remain constant. Which type of data we are sending, it will be the maximum 1500 bytes. This need generated this frame will say how this frame gets generated. Data is coming from top layers and it comes to the NIC. And when NIC encapsulated the data with source MAC and destination MAC and then attach some mathematical calculation to it, then we call it this type of data packet frame. So frame, the name will be different at different layers, but right now we are talking about frame, so it's a frame. MAC address belongs to this NIC. This NIC has a MAC. That is a source MAC. And this guy has a MAC address, that is a destination MAC address. He knows its own MAC address, this machine. How it can know the MAC address of the other machines on the network. When it's sending first time the data, how this guy will know the MAC address of others? You give me the table?
So it's two-way communication. So when he sends a packet, that would be like the first packet is kind of introduction. Like who is this with the MAC address? So it sends to destination MAC address, and then it will, as we said, that it will go to all the devices, but the device that the packet or the frame belongs to will reply saying, yes, it's me, and then they will start.
If it's a hub and you're saying if these devices are connected to hub, each device is, then it's going to send the data to all of the devices, all of the ports, and then the PC is connected to those ports. Then the data, it belongs to this MAC address that we receive. But the thing is, this guy is, the name is A, this guy is a B, this guy is a C, this guy a D. Now this guy wants to send the data B, and you're saying they will first send the introductory packet?
No, actually, if it's a hub, and it's gonna be sending to all the nodes every time. Each device, they will not know where they're sending, so it's gonna send to all the devices. And if it's a hub, it will send to all devices all the time.
So in this case, if it's a hub, how he can identify B has this MAC address and it will need to attach that destination MAC address to this frame?
First, somebody needs to know where he wanted to send, and then the MAC calculate what's the exact address which users want to send it.
But this device we are talking about right now, it's too stupid. It cannot identify anything. It can does.
Is the hub had a MAC address?
No, it's a switch.
Is the switch has a MAC address?
That is correct. So anywhere that it is connected to, the exit port. So destination would be the exit port of the device where it's connected. So it can be that the device or the hub that the PC is connected. So it will send it to the MAC address of the hub because that has an NIC card, and then hub will send it everywhere.
So when you think hub has MAC address, so it will send to that MAC address.
Yeah.
Where that MAC address is. Over here, these PCs, A is sending data B. A has NIC card. On NIC card, MAC is embedded. B has NIC card. MAC is embedded there. on switch. Switch has, for example, hub has will be 8 ports. So each port will have a different MAC address.
One.
Where that will be.
Where it's open?
Yeah. These, see, we have 8 ports here. Right? Other than that, do we have any port?
No.
We can connect any computer anywhere. Does it stop to connect any device? Does it saying don't connect here?
No.
No. Where is that at?
It's a W line.
It's a different device, so I'm not going to take it as an example. But the thing is, each and every port on hub or PC, they are just helping us to connect the devices. And in hub and switches, the switch builds the MAC tables to identify the devices, so that's not a stupid guy. This one is a stupid guy. What it will do, as the packet is coming, frame came to this guy, it will make the copies. It will receive the data where that device is connected to. And there is no management port attached to this hub. No. Can you find anywhere a hub that has a management port? It's not a manageable device. If it was a managed device, then it will need a switch. So just this device is connected here, one end, and it's receiving whatever it will receive here, it will make 3 copies, A, D, and B, and it will send out. And this will check, okay, this packet has this MAC address, it doesn't belong to me, it will drop the packet. Fine.
Yes.
The second, it will come to B, we will say, okay, this my address, the destination,
Stay.
drop. No, it's coming from, it's a C over here now. The example should be changed. Yeah, and then if data belongs to B, it will keep it, right? And all other ports, the devices connected to that hub, they will discard the packet. It doesn't belong to us, but it keeps sending the packet like this. So how machines knows the MAC address of other machines on the LAN, we gonna discuss later.
Only the sender knows. Only the sender assign which PC you wanted to send. Just like mail. You should put the exact address to and then send it, and then will go to the exact person. That's how it works.
I'm just leaving this question in your minds. Keep thinking over it throughout the course until we touch this topic. The thing is, right now I just want to introduce you guys a friend.
Yeah, before we go to the break, we were discussing how many make about the unique MAC address. So we were
Yeah.
so
So as just I wanted to tell you, let you guys know, if we are saying my PCs have unique address across the globe, my device can have 2 unique addresses. Both addresses are associated with my PC. So whatever the data either it's coming to on one address or the second address, it will come to me. So if it's a college, 4th floor belongs to computer, and if we have the 3rd floor as well, and someone is writing 3rd floor, it will come to the same college, right? Address. Then college has 2 floors, floor 3 and floor 4. And if someone is writing for floor 3, mail should come to college. Floor 4, mail should come to the same college. So same as we were discussing a couple of days back. So the servers and the PC. Server is redundant. Server has more than one NIC, right? So all NIC has unique MAC address associated with this, embedded on it, right? So they have more than one NICs, but the PC is unique. But having more than one address, those addresses should unique across the globe. That address should not be given to any other device. For example, I have two MAC addresses. Those MAC addresses should be just only for me, not for Andy or anyone else on the planet. The issue is when we have the same address associated with more than one device. As the if I'm living somewhere, I have an address, and the same address someone else is using, can he use? He cannot. The mail will come to my house, not to his house, right? So the address should be unique. And these addresses are unique across the globe. How these are unique? Different vendors are making these devices. These next vendors are, there are multiple vendors outside. And then how this address is unique even then? Not only within that vendor, it's actually unique across the globe. All is happening.
You should apply.
We have to apply
Yeah.
what?
Apply the address to from IEE.
Like availability. It's not using. This is not already used. So we will embed this to this product. So this will be unique. This is for this one. That's it.
Then there should be some central body, right?
Yeah.
Then what do you think? You have really good ideas. I mean, why you are so silent, man?
I'm observing, sir.
Me is not talking, Frank is not talking, and Simon is not talking at all. Keep talking, guys.
Each vendor has his own.
No, we should apply. From the
Apply vendors.
So
This is the name.
the first two, like 8 bits, are assigned to each vendor. Each MAC address, so the first 8 bits, so there are like 4 and 4. These two are assigned to each vendor. And then the remaining, the vendors will have their own unique addresses that they will assign depending on the devices that they have, their own unique.
He is right. So if MAC address, as we were discussing, we have 4 groups, right? For example, FA 89 21 F0 2B 1 2 3 4 5 and then what?
See,
Zero, zero.
Okay, 0 0. One, two, three. So in total we have 6 groups, right? First 3 groups belongs to, what did you say? So it's a OEM portion of MAC address. What is OEM? So original equipment manufacturer. So he was saying IEEE. What is IEEE, right?
I don't know. I'm an IEEE member. And that is the standardized.
What its role is here? IEEE. Does it take care of these things? ICANN. Who is the parent company? Ayana or ICANN?
That's a difficult question.
Okay, I can expect
IE
difficult answer.
stands for Institute Electrical and Electronic Engineers.
Yeah, good. Thank you for sharing.
Thank you for the best in Google.
I think Ayana is the parent.
ICANN is now parent, but child took birth first. Child came into existence first, and then they made its parent, right? So Ayana was first company that was USA based. That was a government agency first, and they were issuing, taking care of all these address space issues and other protocol issues. And then there were some countries on the planet who are not confident dealing with the US based company, right? So they made a ICANN, and then Ayana started serving under ICANN. ICANN is just like a non-profit organization. It works like this. As CompTIA, what is CompTIA? CompTIA is a bunch of investors together, working together. So they assigned these first three groups of MAC address to OEMs. Dell, HP, IBM, any company, right, outside who are manufacturing these parts or these PCs, right? They handed over these three groups of MAC address to those companies, and the rest comes from those vendors. They keep adding. First will be this one. And for Dell it can be only one. For HP can be only one. All products belongs to HP will have appended number, and the appended number will come from HP itself. So the first it shows the vendor. This make the equipment unique across the globe. That address gets unique with this number when they add that number. Multiple devices are there, they can have this first because the vendor is same, right? If I can wrong slide is there. So there are a bunch of IP addresses out there. Which belongs to which? For example, we have this IP address, this one, D4C9EF52AECA. It will be unique across the globe. The first three digits belongs to this Intel guy. MAC address, sorry. The guys from back countries don't understand what's the time is there. But for them, they are right, it's daytime here. Who's call? Again me. So the first digit belongs to all Intel products may have the same number, and the rest three should be make it unique. And then we have another address here. This one is a MAC, and then we have these IP addresses. See how beautiful address is this: 169, 254, 105, 234. And what type of address this is?
169 Apipa.
So these are the physical addresses embedded to NICs. And then how we identify the MAC addresses while sitting on the LAN or while sitting anywhere on the globe, we attach some logical addresses to those NICs as well. This MAC address cannot identify which network this PC belongs to. Either Fatma's PCs belongs to the same network, and Jun PC belongs to same network. They have no idea. So only we can divide different pieces into different networks or groups using this when you know everything, so now you say so logical address. So each device has physical address, and we can associate one or more than one logical addresses to same device, same network adapter. Our network adapter physical address will be one, but the logical address can be more than one. But usually in colleges, when we are doing the labs, we associate only one address to one physical NIC, and that is and who introduced logical addressing again? So we will discuss this logical address. I'm purposely leaving a few questions. So then we're going to discuss when we will discuss IP addressing in detail. So today's we were talking about the network adapters, physical addresses embedded on those network adapters from where traffic starts and where it ends, right? So it's starting and ending point on both ends is MAC address. And if the source MAC address, we are talking about the source network adapter, the traffic gets emitted on the upper layers, the data, we start compiling the data and it comes to the network adapter. And network adapter encapsulated it in the form of frame and it sends out. On the other hand, when data received by the destination network adapter, it says, okay, this address belongs to me. It just keep the source address just in case it needs to send back the traffic. It keeps it in its own memory, the same source address, and the destination is discard because it knows this address belongs to me. I don't need any more. So it keeps the source address and sends the data to the upper layers. So it will be taken care by our system, right? So in this way data keeps flowing. But the first thing is connectivity, right? So we wanted to check the connectivity by installing some VMs. Do we able to copy the ISOs or not yet? You started, man. You started very slow, right? So it's done.
Yeah.
So everyone has 4 files now. One for VMware Workstation and one there is Word file. I didn't check what type of that file is, but there should be some keys on top of it. Use any key and install that VMware workstation. Just open that file like this. For example, I have over here VMware workstation, this one. There is VMware workstation exe file. Just double click on it.
Which one?
Just go to your C drive where you put the files and double click on VMware workstation, the exe file one. At the end we have exe.
It's a key one.
So I'm coming to everyone. So guys, would you like to stay after 1 o'clock a little bit? Let's create at least one virtual machine. So then we can. So open your VMware workstations. I have this icon here. So let me remove few of them. I have a lot, plenty of things. So
Sharif is behind. He updated his computer.
so Shiv sir will be able to pick later. I'm just deleting you. You guys don't need to do anything. What the problem?
Not finding the key. Not able to find the key.
Google it.
किसान से खाने आ रही हमें भी पढ़ाने का
Not yet. What are you doing then? So guys, please click on this, create a new virtual machine. And then we will go with the typical one. And we have three options here: installer disk image file, or I will install the operating system later. What if we go with the third option? Just one click next. No, not lot of. Here we have options. It's the thing, these options are available here. Assume if you are preparing your physical server, right? And you guys have bare metal physical server. Simon, any issue? So if we are preparing a new server, new hardware, nothing on top of it, the new servers always come with the vendor CDs. And when we run the vendor CD in our new server, during the different steps while we are going through, they ask us, okay, what type of operating system you are intended to install on top of it. So guys, when we buy a new server, then when we prepare the server, these steps comes up. okay, what type of operating system you have a plan to install on top of me, right? So it asked us either it's a Microsoft, Linux, Novel, Solaris, VMware, or other, right? Whatever we will choose, if I'm choosing Microsoft, you guys can drop down here. So we have bunch of options available, right? If we want to install Windows 10, we will choose Windows 10. If 7, Windows 7, if 8, anything, right? So then when we will insert our operating system CD in the system, then system already hardware knows what type of operating system is coming to me. It's accepting the same operating system we will choose over here. If not, what it will say? It's not gonna let you install anything else. So if I'm coming back, click on back button, click on this back button, one step back, and the second option we can install the image right now. Choose the middle one, choose middle installer disk image file. We have image files, right?
Yeah.
So click on browse and then browse to C drive. You have put your softwares there, right? In my case, these are on E drive, and then I have a software folder somewhere. Yeah. And then I have Windows 8. I gave you guys this file, Windows 8.1 Enterprise, February 6, 2017, right? Just double click on it or just simple click and open it. And it should look like this, Windows 8.1 detected. If it's like that, then please click on next. And now please label this machine. We are in Network Plus class, or you guys can use NET. So Network PC1, no space. Network Plus, sorry, Network PC1, NETWORK PC1. It's like I'm giving you guys the name Network NETWORK, then PC and the one digit. It doesn't matter, it's a label. It's not name change, it's just a label of this machine. It will show up or right here. See on the top you have a home button there, home tab. It will come besides here. Network PC, as you guys have PC, right? Or should we go more simple name? No problem. So guys, please click on next. And now the maximum size of disk we need to decide, or we can go only with maybe 30 GB. Just type 30. And then next. And then click on customize hardware. This button. We will discuss these steps again. We will be going through again and again. So first time just install an operating system. So simple. See, right now we have 2 GB. We are on memory, and on right side we can select 4 GB. Just grab this bar pointer and then move it to 4 GB. 4 GB means it should be 4096 in MB. Why it should be 4096? If it's 4095, then hmm? So that's not going to work. It should be divisible by 4. The memory, whatever we are assigning, it should be divisible by 4. So 4 GB is exact 4096. So then please on network adapter, click on network adapter on left side, left pane, and then click on this custom one on your right side. We need projector, right? It's hard to see. So in custom, just please drop down this one to VMnet 2. Tomorrow we will be discussing these options again when we will install the second machine. And then please click on close. We have customized our hardware. And then click on finish.
लाइसेंस के आप गूगल से लेना चाहिए
हाँ गूगल बस गूगल कर दें उसको
रजिस्ट्रेशन फॉर्म गूगल लेना चाहिए
जी
लाइसेंस की या सीरियल
जी
लाइसेंस की और सीरियल
just type VMware Workstation Pro 12 keys and license key if it's written or already get filled, it's okay. Yeah. So guys, now please on this window let me know basically what we are doing there. What we are saying, okay, we went to the shop and now we are asking, okay, for example, June is a shopkeeper, right? I'm asking up, okay, man, can you please give me a PC with 4 GB RAM? It has a PC that is with 2 GB. It will remove 2 GB and will install 4 GB for me. I'm asking him, okay, man, I don't want the DVD drive. Can you give me Blu-ray? It will install for that for me, right? I am asking, okay, I need 60 GB RAM. It will give me 60 GB RAM. When in virtual environment we are customizing the hardware, we choose those options. We could stick with 2 GB. That will be slower, right? So 4 GB will be a little faster. So everyone on this page now?
No.
Not yet?
Yeah.
So then if you are on this page, just click on next and then click on install now. Yeah, it will.
Just like, no, there. See?
Yeah, then please accept the license. Check. then next, and choose custom one. You have done in your A plus plenty of times. So click next and then let it install. So leave the machines on. If you guys want to leave, it's okay. I guess in your case it's gonna take very long.
5 minutes.
Let's give it just only like 10 minutes.
So just give it a name now, the same what we labeled it. Give it the same name, network. Network PC 1. Everyone is on the same page now? Not yet.
Starting.
You please click on next after giving the name network PC1. Click on next and then click on use express settings. Customer express settings. So guys, just for caution, whenever you guys falling behind, please stop me because my system is a little faster. So otherwise I will be finishing the lab. So Saurabh made me laugh. Yeah, I have 32 GB RAM, 1 terabyte SSD.
SSD.
So please, if you guys are on this page now, please create a local account. Click on create a local account, and then give it a name admin, ADMIN. And what should be the password? So W capital ELCOME 1. Welcome 1. We will use this password throughout our courses, throughout the year. Welcome 1, and we will be, on the same page for this. We are not going the unique ones, because if someone is, forget the password, our lab will be messed up. So welcome 1, W capital. So repeat this password. Yeah, hint just capital W and then do finish. Click on finish, and it's Windows 8. It takes a lot of time to set up the hint capital W. Show you how to shut down, and then we will start from here tomorrow. Just on the tab we have for this machine, right click and then power and then shut down guest. Whenever we will leave the class, we will gracefully shut down our VMs first and then physical machines. So click on shut down and then shut down.